Now let's talk about evaluating logarithmic functions. This first example says evaluate f of x equals log base 2 of x for f of 1. Well, we know that with evaluating functions, this means the input for x is 1. So to start, we replace x with 1. Now I'm solving a log base 2 of 1. I could also replace my f of 1 with y. That's the same thing as y. F of x is the same thing as y. And then rewrite it exponentially. So start the base, log base 2. Logs equal exponents. The exponent here is y. Will equal what we took the log of. Well, the only way to get 2 to the y to equal 1 is if y equals 1. Right? So anything to the 0 power is 1. Let's do part B, f of 64. So f of 64 is log base 2 of 64. Again, we can rewrite this exponentially. Start the base is 2. Logs equal exponents, so this whole f of 64, that's just y, equals 64, which is what we took the log of. I can rewrite this exponentially. We factored 64 in previous videos. 64 is the same thing as 2 to the 6th power. That means y has to be 6. And for both of these, if I wanted to rewrite it in that function notation, this is really f of 1 equals 0, because I'm replacing y with back into my function notation. And then part B would be the same thing as saying f of 64 equals 6. So again, just going back to that function notation. Go ahead and try the 2 examples on the right-hand side. In this example, we are asked to evaluate f of x equals log base 3 of x for part A, f of 27. When we are evaluating functions, we replace our x with the input, and the input here is 27. I could rewrite f of 27 as y. Right? Our f of x is the same thing as y. I'm going to rewrite this exponentially. We solve logs by rewriting them exponentially. Log base 3. So I'm going to put 3 for my base of my exponential form. And logs equal exponents, so this equals y. And 3 to the y will equal 27. I could rewrite 27 as 3 cubed. So if I factor that, it's 3 times 3 times 3. Now if they have the same base, 3 to the y equals 3 cubed, and y must be 3. Also back in function notation, f of 27 is 3. Alright, part B, f of 1/9. So again, plug in 1/9 wherever we see an x. Rewrite it exponentially. The base is 3, log base 3. Logs equal exponents. This equals f of 1/9, but that whole f of 1/9 is the same thing as y. Equals, the only number we haven't used, 1/9. And 9 is the same thing as 3 squared, but I don't want that 3 squared in the denominator, so I take the reciprocal, which makes the exponent negative, and that means that y must be negative 2. And going back to my function notation, f of 1/9 will equal negative 2. So the steps would be replace your f of x with y, plug in your value for x, rewrite it exponentially, and then solve from there using perhaps the uniqueness of b property. Well, uniqueness of b to the x power.